Hi everyone. So today we'll discuss some of the part from summary of week 4, which is left, and then we'll take doubts from week 4. So some topics in the last summary session for week 4. I'm audible, right? Just want to make sure that my screen is visible and I'm audible. Am I audible?
Yes.
Okay. So let's start with some topics that we didn't cover in the last summary session. So first is your multiplicity of zeros. So when you have a polynomial, then let's say it's an n degree polynomial. So if degree of your polynomial is n, then the maximum roots it can have is n, right? And by roots we mean the real roots. Obviously, the maximum number of roots. So maximum number of roots is n, and the roots can be the number of real roots can be less than n, right? So a number of real roots are going to be less than n, and so that means if you have px, then the next thing is multiplicity of zeros. Let's say roots or zeros are equal in number, right? So if you have n number of roots, that means n number of zeros. So multiplicity, let's come to multiplicity of zeros. So multiplicity of zero, let's say you have a, which is a zero, then a is a zero, then multiplicity of 0a is k if x minus a to the power k divides px and x minus a to the power k plus 1 does not divide px. This is the symbol for divides. This means that x minus a to the power k, this is a factor of px, right? This is the symbol that we use for divide. This means x minus a to the power k divides px.
I didn't understood this part.
What
If you can come again on this part.
is the notation? If I write a, this means a divides b. So if I'm writing multiplicity of 0 is that means, let's say you have px equals to x minus 3 square, x minus 1, and x plus 4 cube. Then we know what are the zeros of this polynomial?
3, 1,
Zeros
1.
of this, right? 3, 1, and minus 4. Now multiplicity of zeros, let's see multiplicity. So multiplicity of 3 as 0. 3 is a 0 of px, right? Is 2. Why? Because our definition says that x minus a to the k is the multiplicity of a 0 if x minus a to the power k divides px, and x minus a to the power k plus 1 does not divide. This means does not divide px. That means your x, this will be the multiplicity if x minus 2 cube divides your polynomial px. Sorry, we should have written 3 here and 2 here. And x minus 3 cube does not divide px. So this basically means that the maximum power of this factor that can divide px is the multiplicity of that 0, right? So the maximum power of this x minus 3 factor is 2. That's why the multiplicity of 3 is 2. Maximum power of this factor that you get by 0, 1 is the 0, 1 is corresponding to this factor, right? X minus 1. And the maximum power you see here is 1. That's why the multiplicity of 1 is multiplicity of 1 is 1 and multiplicity of minus 4 is 3. Is that okay? Is this clear to everyone, the multiplicity thing? You don't have to do, this is the formal definition for the multiplicity of a root. This one, this x minus 3 square divides px and x minus 3 cube does not divide px. That means 2 is the multiplicity of root 3. That's the formal definition. You don't have to check for this thing. You can just clearly see from here that the maximum power of x minus 3 factor that can divide px is 2. X minus 3 cube cannot divide px, right? That means if you have been given a random px, let's say, if you have been given a qx, then to find the multiplicity of zeros, what do you do? How do you find the multiplicity of a polynomial of zeros in polynomial qx? You first factorize them, factorize this thing into its linear factors, and it's not always possible to factorize this thing in linear factors. Maybe if this has degree 5, if qx has degree 5, then it's pretty possible that all of your roots are complex, and or at least a few of them are complex. So like this one, let's say you have x square, if you get a factor x square plus 1 and x minus 1, right? Now it only has one real root, which is 1. So you'll only talk about the multiplicity of this. So all in all, you might not be able to write every polynomial as product of linear factors. There could be quadratic factors that can't be further factorized, and there could be cubic factors too. Cubic is not possible because one of the roots will have to be real. If you have, then this next point is if you have 3 roots, let's say you have 3 roots, 5 roots, or 7 roots, or 7, if this is the degree of a polynomial, this implies at least one root is real. Because complex roots appear in conjugates. So this, if the degree is 3, then all 3 roots cannot be complex, right? For example, let's say you can take this one. Now this has the total, the highest power would be 3. So the degree is 3, right? So if you have x square plus 1 and x minus 1, then the degree of this entire thing is 3. So it's confirmed that only one root, either one root is, so what are the possibilities? Let's say you have qx here instead, or tx. Let's say your degree is 3. Then what is the possibility? How many real roots can I have? Appear in conjugate means that is, if a plus iota b is a root, then a minus iota b is also a root. That means if the degree is 3 and all the roots are in complex numbers, so if this is a possibility that you have a polynomial and all of its roots are not real, right? Like this one, x square plus 1 and x square minus 1. Let's take this polynomial. So if this is the polynomial, then its degree is 4, and all roots, what are the roots of this? What are the real roots? What are the real roots of this one?
X square is equal to -1 and +1.
How do
X
you
square.
find roots? First, if you want to find the roots of this polynomial, then you equate this polynomial equal to 0, right? So you'll have x square plus 1, x square minus 1 equals to 0, right? And then you will check for each factor. When each factor, if this factor is 0, then this entire thing will become 0, right? So one possibility is x square plus 1 is 0. Other possibility is x square minus 1 is 0. Now from this one, this equation gives you x square equals to minus 1, which is not satisfied by any real number, right? Now that means it does not have real roots. It doesn't mean it doesn't have roots. We'll come to this one later. Now coming to this one, this has roots 1, so the x will be plus minus 1.
Plus
Right?
minus.
So you'll have two real roots from here, plus 1 and minus 1. But from here, you don't get any real roots. Doesn't mean you don't get any roots from here. So if you do this, you'll have iota from here. X will be plus minus iota. So the roots that you get from here are, and this is not in your syllabus. Why we are doing this here is the roots that you get from here are plus minus iota, and both of these belong to complex numbers. So by the point here is, point that I'm trying to make is, every root of a polynomial might not lie in real numbers, in the set of real numbers, but lies in the set of complex numbers. That if you have any root of a polynomial, it might not be like this one. This is not in real numbers. It might not be in your real numbers set, but it will be in complex numbers set. That means, now if you will have root, now this one, the degree is 4. So similarly, let's say out of which 2 are real roots and 2 are complex roots, right? And complex roots from here, the point is, the other point to keep in mind is that complex roots always appear in conjugates. That means if you have a plus iota b as a root, like in this case, 0 plus iota is a root, so 0 minus iota is also a root. That's how the complex roots appear. 0 plus iota, 0 minus iota. A plus iota b, a minus iota. That's how roots appear in complex numbers. So if you have this example, let's say, where you have been given a polynomial px and the degree of px is given to be, let's say, 4. Then what is the possibility? How many real roots can I have? You have 4 roots, out of which if you'll take one real root, let's start from 0. Can I have 0 number of real roots for a polynomial with degree 4? That means if you have 0 number of real roots, that would mean that all the roots are complex. Is that possible? Can you have 4 complex roots for a polynomial? You'll have 4 complex roots then, right? Because if you have degree 4, that means you'll have 4 roots, but all of those 4 roots would not lie in real numbers. Some would lie in complex numbers. Other can lie in real numbers. And what's the rule here? The only rule is that the ones that lie in complex numbers, they always have a conjugate pair that's also a root. That means if a plus iota b is a root of px, a minus iota b should be a root of px. So if you have four complex roots, that's possible, right? You can have complex roots as a plus iota b, a minus iota b, c plus iota d, and c minus iota d. Now you have four complex roots. That's fine, right? That's not a problem. Can I have one real root? If I'll have one real root, then I'll have three complex roots. Are three complex roots possible for a polynomial?
No. No.
Right, because if you'll have a plus iota b not possible, then a minus iota b should be a root. These are two roots. And then if you take c plus iota d, then c minus iota d should be a root, right? But that's not possible because these are only three complex roots are possible. If one is real, then only three complex roots can be uh, there, right? So that means this case is not possible. So all, if we have to generalize this thing, this would mean number of complex roots is always even, right? Because they appear in conjugate pairs. So the number of complex roots should always be even. So if you have degree 4, then 2 roots can be complex, 4 roots can be complex, or 0 roots can be complex, right? Now, if you have degree, let's say 5, if degree of px is 5, then how many real roots can you have? How many complex roots can you have? Complex as in not real roots. How many roots will not be real?
2, 4.
One real and four complex, or else two,
2 or 4.
three reals and two
or
complex.
3, 2.
So the number of, let's start with purely complex. So number of purely complex, by purely number of non-real I should be writing. Number of non-real roots possible is either they can be, because they appear in conjugate, so this number is going to be even, right? So either they can be 0 or 2 or 4. So number of real roots or number of purely real roots, because real roots are also complex. Real set is contained in the set of complex numbers. So the correct terminology should be number of purely real roots. Should be, now if you have 0, that means it's 5. If you have 2, that means 3. If you have 4, that means 1.
5,
So 1, 3, and 5. So for your roots to lie exactly in real numbers, either there could be just one real root or three real roots or five real roots. Is this all clear to everyone? Multiplicity
There
and
are
this
5 real roots, then 5 can't be in a pair, conjugate pair. Either it should be 4 real roots or 2 real roots.
real roots are not okay. Real roots don't have to be in conjugate. Complex, purely complex, non-real roots
Purely
have to be in conjugate. Not even
it's a
purely,
non-real.
yeah.
Yes, yes, yes.
Non-real roots
Pair.
should be in conjugate
Purely real.
pairs.
Okay. Mean 0 complex roots, then we have 5
Yeah.
all real roots. Okay. Yeah, makes sense. Thank you.
And it's a small thing that I want to point out is don't say complex roots because real roots are also complex roots. So the better term to use is non-real roots because real roots are also complex. Real set is contained in the set of complex numbers. Okay. So let's then come to graphing of polynomials. How do you graph polynomials? So for this, the first thing is obviously first is let's say you have px. Then the first thing is about the x-intercepts, right? First is you can use
X
x-intercepts.
intercept.
Second is you can use y-intercept. You can only have one y-intercept. X-intercepts could be many. And then third is the multiplicity of roots help you. And I'll tell you how it helps you. Multiplicity of roots. And fourth is, let's say you have things as, you have a polynomial as x minus a, x minus b, and let's say an x minus c. Then you can clearly see there are three roots, three real roots, and you can test the numbers between them. If this is a, b, c, then to figure out if the graph is on this side or this side, you can put the numbers between a and b. So if you'll put a number between a and b and you get a positive value, that means your graph should be like this, right? Or it could also be like this, but it will lie on the positive side, positive y-axis, right? If you take a number
Yes,
between
ma'am.
a and b and it's positive, you substitute that number here. Let's say that number you've taken is k. If you've taken k between a and b and you get pk to be positive, that means this is going to happen, right? And you notice that you've only checked for one number, but it's true, if you've checked for one number between a and b, then it applies to all numbers. Why? The point here is, let's say you have this, and these are the only three real roots, right? And let's say this is the order of roots. B is greater than a and c is greater than a, and there is a number k between a and b. And for this particular number, we have taken a particular number between a and b, and for that number, the value of this polynomial is greater than 0. Then this should only mean that if you have a here, b here, c here, and k is here, let's say, then the value at k should be positive, right? This is what it says. What about the other points? How do we know that at the other points too, the value of the polynomial should be positive if it is positive for at this point k? At this point, the value is positive. That means the height is positive. What about the other points? Is it feasible for us to check for every point? Not right. It's not possible.
Yes.
Then how you don't have to check for all points. That's the good part. You can check for one point between A and B, provided you're sure that the next root immediately after A, the next root is B. There is no other root between A and B. So if there is no other root between A and B, and the value at K is positive, and polynomials are okay. Before that, I'll discuss one more point about polynomials, which is for graphing of polynomials, they are continuous in the general, in the graph sense. Graph sense as in, what do you understand by continuity? Continuity, this is not what, the thing that I'm going to say is not what continuity exactly means. But here, when I say continuous, I mean this thing, that they can be drawn without lifting the pen.
Right.
So, yeah. So polynomials or polynomial graphs don't have any breaks. And the second is they don't have sharp corners either, or sharp turns. That means if now let's just see, let's take some examples. Let's say you have this thing. Then can this be a polynomial? So this is not a polynomial because you
Continuous.
need to lift pen, right? So in your very layman sense, this is not a continuous function, right? So that's why it's not a polynomial, because for you to draw a polynomial, you should be able to do it without lifting the pen or without having any breaks. So we have a break here. That's why this is not a polynomial. And second thing is, it should not have sharp turns. Sharp turns mean this. It means this. It means this. This is a sharp turn where you were going like this and then you suddenly took a turn. So this is a sharp turn. That should not happen. So if your graph is like this, or it's like this is a sharp turn. This is also considered a sharp turn. So sharp turn. So this is not a polynomial, and this isn't a polynomial either. One example that you can take is mod of x. So how do you plot mod of x? The graph of mod of x. This is basically x when x is greater than 0 and minus x when x is less than 0.
Okay.
So the graph looks
So
like this.
we should
Now,
sharp corner.
what about this? This is the sharp corner, and that's why it's not a polynomial. And you don't need the graph to know that this is not a polynomial. You should know that this isn't a polynomial. Why? X is a polynomial, minus x is a polynomial. But if you will take distinctions, different branches here, then it's not a polynomial, right? You're saying for some part of x, it's this, for some part of x is this. This is not a polynomial. Fx equals 2x plus 5 x cubed for x greater than 3, x less than 3. What about this? This is also not a polynomial. Is this okay? For you to know, the easiest way to check it is again to compare it with your usual form, the general form that you have with for polynomials, and you can't do that for this one. Because though this part separately and this part is a polynomial, but they when clubbed together don't form a polynomial, right? This isn't a polynomial. Neither is this. This isn't a polynomial either, and this is not a polynomial either. Is this clear to everyone?
Yes.
Okay. Now let's come to this one. If you have A, there's a root here, and there's a root here, right? And then so A is a root, and the next immediate root after A is B. So no roots between A and B, no roots between B and C. And the other information that you have is that your polynomial's value at K is positive, right? So if at this point you have let's say at this point you have a negative value, right? If your polynomial takes negative value at this point, and we know that you should not be lifting your pen, right? So if your polynomial is like this, how will you go from this point to that point? You'll have to connect these 2 points, right? Can you go from this point to this point? Because you'll have to connect them, because you should be able to draw the graph without lifting your pen, right? So you'll have to cross this line here again. And this means that at this point, your polynomial will get 0. But we said the immediate root after A is B, right? That means you can't have a 0 here. That means if the value here is positive, then the value of all the points at all the points here should be positive. Otherwise, you'll have to have a root between A and B. Is that okay? This is also a result which is about, let me write that result only.
Intermediate value theorem.
Yes. It's intermediate value theorem, or in easier, simpler words, it is, intermediate value theorem is a little more complex than what we'll write here. This is the thing that I'm going to write is a consequence of intermediate value theorem. It's not intermediate value theorem. So intermediate value theorem implies this thing. And you don't need to learn intermediate value. We'll do that too. So first, the intermediate value theorem says this. That if, let's say, shall we do it with an example? Because I think A, B, C confuses everyone. Shall we take up an example instead of going by the proper definition? So let's say you have Px equals to, or not just Px, if you have Okay, let's discuss polynomials. If you have polynomial px and p at 3 is 0, that means, and p at 4 is also 0. That means at 3 and 4, you have 0, or not 0, let's take p of 3 equals 1 and p of 4 equals 2. That means at p of 3, you have this 1 value, 2 value. At p of 3, you have 1, this value, and at p of 4, you have this value, right? This says that if you will take any height between these 2 points, that means 1 is the height attained at point 3, 2 is the height attained at point 4. If you will take any height between 1 and 2, let's say you took this height, 1.5, then there should be a point between 3 and 4 at which your height is 1.5. So if this is your 1.5 height, you should have a point here, somewhere here. It doesn't have to be exactly in the middle of 3 and 4. It could be here. So that means for any k between 1 and 2, there should exist a point x which lies between 3 and 4 such that the polynomial's value at x naught should be 1, should be k. Now what does that mean? If you take a number between 1 and 2, your 1 and 2 are here, and the values at 1 and 2, 3, 4, that's here. So if you take any number, no, you took the wrong thing. 1 and 2 is here, and 3, 4 we have to take on x-axis, right? And 3 and 4 is here. So if I'll take any number between 1 and 2, in this 1 and 2, this is from the range, this is from the domain. So if we'll take any number between 1 and 2, we should get a number between 3 and 4 such that the polynomial's value at that point. So if you take k here, k could be anywhere in between 1 and 2. It could be here, 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 anywhere. So if you take k between 1 and 2, you should be able to find one x naught between 3 and 4 such that the value of the polynomial at x naught should be k. Is this clear? Should I repeat it one more time, or is this theorem, the intermediate value theorem, clear to everyone?
It's clear.
This is the formal definition, and this is what it means graphically. If you take a point between 2 points in the range, these 2 points are in the range. If you take a point between 2 points in a range, then you should get a point between 3 and 4, where 3's image is 1, 4's image is 2. So you should get a point between 3 and 4, such that that point's image is k. If you will take another point k naught here, let's say you took k naught here, for k naught you found x naught between 3 and 4, such that p of x naught is k naught. And for k1, you can find a point k1. If the k1 could be here. Now, okay, let's do this thing. If your k1 is here, this point is, and so your function's value, polynomial's value at 3 is 1, x naught is k naught, and at 4 it's 2. And I've taken a point between 1 and k naught in the range. K naught is in range, 1 is in range, and I've chosen another point from the range. I've chosen another point between 1 and k naught, which is k1. Then where should its pre-image lie? where should that point lie whose image is K1? Should it lie here? Should it lie here? Or should it lie in this interval where?
Yeah, 3. Between 3 and x0.
Yeah, correct. So it should lie here. Your x1 should lie here because 1's image is 3, k0's image is x0. So anything between 1 and k0, that element's image, pre-image, should be between 3 and x0. So image is this, where you have a domain, there's a range here. So this is called, if you have x here, fx is called the image of x, and this is called the pre-image of fx. X is called the pre-image of fx under f, right? I hope this part is clear to everyone, and the consequence of this is, now let's say you have P3 equals to greater than 0. Let's say P3 is greater than 0 and P4 is less than 0. That means this is a positive number, P3 is a positive number, P4 is a negative number. It's like this. P3's image is, if this is 3, this is 4, then P3 is something negative here. And P4 is something positive. No, P4 is negative, P3 is positive, right? Let's take this to be P3. Here. These are the 2 points. Then what should be the consequence according to that theorem? This is a positive number greater than 0. This height is positive, this height is negative. And 0 lies between this positive number. So if P3 is positive, this should mean that 0 lies between P3 and P4, right? And we discussed that if there is a number which lies between 2 points in the range, P4 is in the range, P3 is in the range. If 0 lies between, not just 0, and if any number lies between P4 and P3, and this all discussion we're only doing for polynomials. This is everything that we've discussed so far is just for polynomials, not for every function that you see. So if you have a number between the 2 images, then that should mean that the pre-image of 0, where should it be? If 0 lies between P4 and P3, what does this mean? That you should get a number between 3 and 4 at which your value becomes 0, right? That means there should be a number between 3 and 4 such that your pk is 0, right? Between these two numbers, you should get a point. If at this point, this is your height, or let's take this instead. This keeps things easier. P3, here you'll have P4. So if at P3 you have a positive value here, at P3 you have a negative value, right? P3 is less than 0. That means the height should be negative here for P3. This should be 3 comma P3 point, and the height is P3. This one is P4. And this point, let's say, is 4 comma P4, right? So this height is P4. This height is P3. Now, if you see, now we can clearly see that if this is positive, this is negative, and that means 0 lies between these two numbers, right? That means you should get a number between 3 and 4 whose image should be 0, right? Where you should have a number k such that at k you have the root of the polynomial. Is this fine to everyone? Can we move to the next topic if this one is clear? Okay, then we were doing the graph. Let's, before start with the graphing part, let's discuss what the domain of polynomials is. What's the domain of polynomials?
All
And
real.
what's the range? Yeah, this is real. And what about range?
Range would depend
This,
on
yeah,
it,
it depends on the polynomial.
but it can either take real or complex.
So it's the range has to be a subset of real numbers only. If your domain is real, then obviously the range is also real, right? If you have this thing, a naught plus a1x, and every number that you're putting here, ak, x to the power k. Now x is also real because the domain is real. A naught, a1, and all of these are also real, the coefficients. That means your range is also real, right? Because real numbers and multiplied together, added together, always give a real number. Is that okay? Okay. Then let's come to the graphing part. Let's say you have, and this last point is about the multiplicities. Right. So about the multiplicity of roots, let's say you have px equals to x minus 1 square, x minus 2. Now this means your roots are, this is 0 here, 0, 0. This is 1 and this is 2. So you have a root at 1, then you have a root at 2. So if your multiplicity is odd, like this one, if the multiplicity of a root is odd, then it crosses the x-axis. That means if, because the multiplicity of 2 is 1 here, that means the multiplicity of root 2 is odd. So it should cross the x-axis either this way or this way, one way, right? This is also possible. This is also possible. This is also possible. That means it touches and crosses it. And if your multiplicity is even, that means, so if you have multiplicity 2, you have multiplicity 4, you have multiplicity 6, that means it touches and bounces back. So either it will touch and go upwards this way, or this is going to happen. Right? These are the only two possibilities. Now let's come to this one. We know that it has a root at 1 and it has a root at 2. So if I'll take, let's say I take 4 here. What I'll do is, we know it's either this thing here or this thing here. We're not sure which one. So let's try to put a value between 0 and 1. If I'll put half here, in this polynomial, then p of half is, what's the sign of p of half? We just need the sign. Negative, right? If you substitute half here, you will get negative number. What number? We don't need
Minus
that.
half.
We don't need the number. We just need this. So you will get a negative number, right? That means, and we discussed this, if at one point between 0 and 1. So, and 0 is not even a root. So there are only two roots, 1 and 2, and then there are no other roots. That means if at half, or you could have substituted 0 as well, that's no problem. At 0 also you're going to get negative sign. This is also negative, right? And at any other number before 1, because you checked at 1 point, half, that's enough. So what happens is between two roots, you have to check between for only 1 point. So like you can pick a number between 1 and 2 and check the value of your polynomial at that point. Pick a number between 1 and minus infinity and 1 because you don't have any roots here. So pick a number here, then pick a number from 1 to 2, and then pick a number from 2 to infinity. And check the value of the polynomial here because your value of polynomial from negative to positive is only going to change when you have a root, right? So it can change here at 1, it can change at 2, that's it. It can't change in this interval, right? The polynomial can't go from positive to negative or negative to positive. It can't change sign. It cannot change sign in this interval, and this interval, right? That means you'll only have to check the value of or the sign of your polynomial at one point in this interval. So let's, from 1 to minus infinity, we've already checked at half. It's negative. That means it's this. Or we don't know the y-intercept yet, so let's not go there. The y-intercept will have to be this, right? So it's half. So at half you have negative value, that means your graph should be this, right? So this possibility that it could be this is eliminated because the value from 0 to, from minus infinity to 1 is negative. That's why the possibility of having this is eliminated, because if your graph were like this, then you will have a positive value at numbers before 1, right? Is this clear? Okay, so that means your graph should go like this. And then because at 1, the multiplicity is 4, which means it's going to turn. So if multiplicity is even, it goes like this. If multiplicity is odd, it goes like this. And because
Even
multiplicity
then
of
it
1,
touches and cross.
yeah. So at 4, at 1, you have multiplicity 4, which is even, so it should go like this. And then at 2, the multiplicity is odd. That means it's going to cross. That's very obvious. You don't have to check the sign here because it's going to be this only. You can simply take this thing, right? And someone tell why we don't need to check the sign here. Between 1 and 2, we didn't check the sign here. For confirming things, you can check the sign. If you'll put a value, a number between 1 and 2, let's take 3 by 2. This will be positive, and this will be negative. So you're going to get negative. I mean, you can, but you don't need to, because your next root is here. So you can't suddenly change sign from here, right? Your graph cannot go like this. If it has turned from here, it will have to do this thing. You have to touch only here. It can't go like this, right? Because there is no root between 1 and 2. So it should go like this. And then it passes by this point, passes the x-axis. So it should be like this. Is this okay?
Then it
Now
will
it's pretty possible for you to, it depends on the number of turning points too. So it's possible for you to have something like this. Like this. Now this would mean that you have 3 turning points here between 1 and 2. This is also possible. This is also possible. We'll have to check this thing. This is how you sketch the graph of polynomials. Is this fine? Shall we do one more example? And then you can also check the y-intercept, because what's the y-intercept of this polynomial?
You put x is 0. 1
So,
has to it put negative.
It's -2, right?
-2.
This is your y-intercept, 0, -2. And for turning points, what you do is, if you have this polynomial, let's discuss turning points too. So your turning points are,
So, degree -1.
graphically, it means the number of times your graph takes a turn. So this is one turning point, this is second turning point. These are called turning points. So this, if you have something like this, then this thing has, for now, 1, 2, 3, 4 turning points. And if it has this thing, then also it has 4 turning points, 1, 2, 3, and 4. These are called turning points graphically.
Polynomial would have n minus 1 turning point at most.
Yes, ma'am, the degree
Yeah.
is 1.
And if you have the degree of a polynomial, let's say the degree of a polynomial px is n, then the maximum number of turning points you can have is n minus 1. You can't have more than that number of turning points in your graph. So here the degree is 5, so you can only have 4 turning points.
4 turning.
And we have had 2 already, right? That means it's possible for you to have a graph like this. Can you have this thing? Because if you will go like this, you only have 2 possibilities. Either after taking the turn, you go like this, or you change it and you don't go like this. You go back and then go like this, right? So here it will be 1, 2, 3, and 4 turning points. That's also a possibility, right?
Yes,
So we've not started with the calculus part. Otherwise, we would have discussed derivatives here to find the turning points and all. But
ma'am. Differentiation.
we don't have differentiation and all in this week, right? Usually, you're not given questions where there'll be confusion like this, where you would not be able to decide either if the graph looks like this or the graph looks like this with just one turning point here. It's not given generally in questions because you're not supposed to use derivatives in this week. But if you're given things, you can just find the derivative of this. This is a polynomial, and the derivative is
On
basically,
chain rule, we can find
yeah, we
for
can
the
do that. But the derivative, my only concern is that we're not supposed to use derivatives in this week. So the derivative of px will be equal to 4 x minus 1 cube, x minus 2 as is, and x minus 4, x minus 1 to the power 4, and this thing. So you'll have x minus 1 cube, 4x minus 8 plus x minus 1. So this is 5x minus 9 and x minus 1 cube. And even if you do this thing, you'll have 1 and 9 by 5. It doesn't solve anything because you're getting your derivative. One derivative that you're getting 0 is at 1. Yeah. This we are sure of. And then The other that you're getting 0 is only at 1. So you only get 1 point, right? Uh, Turning point means, so x is a turning point, or x naught is a turning point of px. Now this should mean that your p dash x, this is the derivative of your polynomial should be 0. So if x naught is a turning point, your polynomial's derivative should be 0 there. That means there's one turning point, second turning point, if there are 3 more turning points here, then the derivative should have been 0 there, right? But it's only 0 at 1 and 9 by 5. There are only 2 points. One is here. 9 by 5 will be somewhat between 1 and 2. But there's only one point where the derivative is getting 0. That means there should be only one more turning point other than this, right? Is this clear? Okay. So then should we also
We
discuss
can
how we
find the turning points easy.
what?
By differentiation, we can find the turning points.
I can't hear you clearly.
I was just saying that differentiation we can find turning points easily. Any polynomial.
Voice is breaking. Uh, okay, shall we discuss how to find the derivatives of polynomials? So we'll do this rule. You will only be given polynomials. Either you will be given polynomials like this: a naught, a1x, plus so on, a k to the power, a k x to the power k. So if your polynomial is given in this format, px, then the derivative, this is the notation for derivative, is, consider this as, so this becomes the derivative of constant, this is constant term, this becomes 0, and this becomes a1, this is x to the power 1, so 1 comes here, and this becomes x1 minus 1. So basically, I'll write here,
And x n minus 1 is the
derivative of x to the power n is n x to the power n minus 1. So this is the derivative. So if you have to find the derivative of 3x square plus 2, then the derivative should be, this is 3. 3 remains, the
6.
scalars remain as it is. And you take 2 here. 2 in front, so this will be 2. And x to the power 2 minus 1. Plus, the derivative of the constant term is 0. Derivative of constant is 0. And this will be 0. So if you will have this thing, you will have 1 in front and then x1 minus 1. Then you will have a2 and then 2 in front because you have a2x square, right? So 2 in front, a2, x to the power 2 minus 1. And then it keeps going on like this. And you end up with k, ak, x to the power k minus 1. This becomes a1 x to the power 0 plus 2a2 x to the power 1 plus 3a3 x to the power 2, and it goes on like this: k ak x to the power k minus 1. Is this okay?
Yes.
So we have found and there's one more rule. If you're given the polynomial in this manner, let's say you have been given px equals to x minus a to the power, or let's say you have been given x minus 2 to the power 3, 3x minus 1 to the power 2, then the derivative is, you keep this, there's a product rule which is because these two factors are in product, then you should write this factor as is, write it as it is, and then find the derivative of this one.
UV
3x minus 1 square derivative, and then keep this as is, and keep the second one as it is, and find the derivative of the first one, the derivative of this. So this remains x minus 2 cube, and to find the derivative of this 3x minus 1 square, okay, you'll need to know the chain rule for this, right? We need to discuss that. So for the derivative of this, what you can do is you keep this power in front. So this becomes 3x minus 1. And then you take the derivative of 3x minus 1. So it goes like this. If you have, I'll suggest you to just write this function in this form and then find the derivative instead. But then you wouldn't be able to do all of this, right? It'll become complicated for you to find the roots because you'll have to factorize it then. This is basically if you have two functions ux and fx in multiplication, ux and bx in product, and you have to find the derivative of these two. This becomes u
DV by
v dash, or I should be writing ux actually to avoid confusion, ux v dash x, and then vx u dash x. This is the rule. And if you have, this is first rule, and the second rule is if you have u of fx, this is about compositions, and I don't think then I'll have to get into compositions too. And I don't want to go there. This is it. You'll have
composite functions will eat fire.
what?
That composition that will be big fire, right?
Yeah, they're in week 5 and all. So just meanwhile, just try to read this thing, how to find the derivatives. You might not need it in this week, but if at all you're given a question like that, it becomes easier for you to just find these things, find the derivative, and then to check that the only derivatives, the only points where your derivative becomes 0, where this thing becomes, this is your derivative, right? So the only points where your derivative becomes 0 is 1 and 9 by 5. That means and if there is a turning point, it should be a point where your derivative becomes 0. That means every turning point of a polynomial should be a root of the derivative of that polynomial. So if x0 is a turning point of px, then the derivative of p at x0 should be 0. Is this fine? That means if you have
Yes,
a turning point here, if you have two turning points here, if you have three turning, if this is your graph, either this is the possibility or this one. Either this is the possibility or this is the possibility, right? So if you have something like this, then you'll have three turning points between 1 and 2. So between 1 and 2, x equals to 1 and x equals to 2, you will have three turning points. 1, 2, 3. That means your derivative, now if there are three turning points, three different turning points, this is x0, let's say this is x1, this is x2, right? So you have three different turning points. That means your derivative should be 0 at all of these points, right? It should be 0 at x0, 0 at x1, and 0 at x2. But your derivative is only 0 at 2 points, out of which one is this. It's 0 at 1, and then it should be 0 at these 3 points too, but you're only left with 1 point. That means this is not possible, right? That means the only possibility for your graph is this. That means this should be the graph. Is this okay?
Yes, ma'am.
Okay. Then let's discuss. This was about graphing, and the other aspect, one more thing about graphing is endpoint behavior or end term behavior, which means if you have a naught plus a1x, if this is your polynomial, ak x to the power k, then your polynomial is like this, right? It's something like this. So end term behavior is this. So this is when x tends to infinity, right? Where does your function go? When your x goes to, this is x tending to infinity here. This is x tending to minus infinity here. Right, on this side, x is tending to minus infinity. On this side, x is tending to plus infinity. So we need end term behavior means if your x is tending to infinity, where is your function going? This is the height, right? Where is your height going? That's called end term behavior. And how do you find it? So you only focus on this thing, the sign of ak here. You only have to focus on sign of ak. So if ak is greater than 0, let's discuss it for odd and even ones first. If your k is odd, let's say, or let's start with even first. If your k is even, let's take an example to simplify things. Let's say you have 3x to the power 4 plus x cubed plus 2. If you have this thing, now if your x tends to infinity, then this thing tends to, you only have to check the sign of this coefficient, of the coefficient of highest power. So you have to only check this thing. And since this is positive, that means this thing, 3x to the power 4 plus x cubed plus 2 should tend to infinity,
10.2.
right? So that means if your k is even, what's k here? K is the highest power, right? Which is 4 here.
Wait, greater
That's
than
why it's
3.
even. What?
That basically the product even and it's greater than 0. So that's why it's 10.
So if your x goes to infinity, this thing goes to infinity as well. How do we generalize it? That means if your k is even, so this is for every, this is not just for 4, this is for every k that's even. If your k is even, if x tends to infinity, this means if degree of px is even, then x tends to infinity and leading coefficient is positive. Leading coefficient means ak, right? So if your polynomial is, let's say your polynomial is summation ai x to the power I varying from 1 to k. If this is it, then the highest degree is k, right? The degree of this polynomial is k. And if your k is even, like in this one, and leading coefficient, that is ak. This thing is a naught plus a1x plus so on, ak x to the power k. So this is called the leading coefficient. This is called the leading coefficient, ak. So if your leading coefficient is positive, this implies x tends to infinity, or I can say px tends to infinity when x tends to infinity. and when x tends to infinity or when x tends to minus infinity. So if your px is this, the degree of px is k and it's even, and the leading coefficient is positive, then your px tends to infinity when x tends to infinity and px and x tends to minus infinity. So it doesn't matter whether your x goes to infinity here or minus infinity. It should always be, so your graph will look like this. N-term behavior means we don't know what's happening here in the middle, but when x tends to infinity, your px tends to infinity. And when x tends to minus infinity here, where x tends to plus infinity. So it's like this. Is this okay? We don't know what's happening here.
Yes.
And the next one is, this was for when your leading coefficient was positive. Now if your leading coefficient is, this is case 1. If your leading coefficient is that means ak. If this is negative, now this should mean that your px tends to minus infinity when x tends to infinity or when x tends to minus infinity. I should be writing and. That means whether x tends to infinity, in the case when x tends to infinity or px tends to minus infinity, and when x tends to minus infinity, then also px tends to minus infinity. So the graph will look like this. At x tending to infinity or px tends to minus infinity, that means it goes down here. And x tending to minus infinity here, when x moves here on the left side, your px tends to minus infinity. That means your height decreases. It becomes more negative. So this should be your graph. Similarly, we have the case for if k is odd. So if your k is odd, example, let's say you have taken 3x cubed plus 2x plus 1. And your leading coefficient, let's say, the first case is leading coefficient ak. Now, if your leading coefficient ak is greater than 0, that means this thing. That, for example, as in this case, if your leading coefficient is greater than 0, then as x tends to infinity, leading coefficient is greater than 0 and degree is odd, like in this case, 3. Then this should mean your px should go to what? So if your x is going to infinity, that means your x cube is also going to infinity, right? And 3 is positive, that means 3x cube is also going to infinity. And this leading term decides everything. That means 3x cube, if is going to infinity, then this entire thing is also going to infinity.
And
That means this will go
infinity
to
then
infinity.
x student.
And if you have x tending to minus infinity, now this means your x cube tends to minus infinity. This means your 3x cube also tends to minus infinity.
Px will
Now this
also tend
means,
to minus it.
right, px will also tend to minus infinity. So this means if your x tends to infinity, px tends to infinity. If your x tends to minus infinity, px tends to minus infinity. And for leading coefficient less than 0, the opposite of this happens. You can just change the signs here. Leading coefficient ak, if this is less than 0, then as x tends to infinity, if ak was positive, this was going to infinity. Now, if this is negative, that means it should go to minus infinity, right? And if x goes to minus infinity, your px should go to,
Infinity.
this one goes to minus infinity, so this should go to infinity. Is this clear to everyone? The relation between leading coefficient, degree, and the n-term behavior. What does the graph look like here? This is x. When x goes to infinity, your polynomial goes to infinity. That means this. And when your x goes to minus infinity, polynomial goes to minus infinity. That means this. Right? And if you come here, if your x goes to infinity, your px goes to minus infinity. That means this. And if your x goes to minus infinity, bx goes to plus infinity. That means this. Is this clear to everyone?
Yes, sir.
Okay. So this was about n-term behavior. Let's do one example based on this. Let's say you have minus 3x to the power 5 plus 7x. Now, if your x goes to infinity, where should your x to the power 5 go? Infinity. And if this is going to infinity, that means your minus 3x to the power 5 should go to minus infinity. And we already discussed this, that the highest term, the highest degree term decides the term behavior. N-term behavior means this thing. When your x goes to infinity, plus infinity, and when your x goes to minus infinity, then where does your y go? That's called your n-term behavior, right? So if your x is going to infinity, then this polynomial goes to, that means this entire polynomial goes to minus infinity. Now if x goes to minus infinity, this means x to the power 5, because 5 is odd, right? What should happen here? If x goes to minus infinity, x to the power 5 goes to what? A negative number which
Will go to
when
minus
raised to
infinity.
odd power. If you have a negative number raised to odd power, this gives you a negative number, right?
Yes, sir.
And if you have a negative number raised to an even power, that means it's a positive number. Then. So x to the power 5 will go to minus infinity.
Minus
And
infinity.
x to the power 4, what about x to the power 4?
Infinity.
Right. So because if you have even power, and no matter whether your number is positive or it's negative, if the power is even, the resulting thing would be positive only. Power even means positive number. So if you have positive power here, no matter what value you choose for x, this will always be a positive number. That means it should be plus infinity. Now this implies your minus 3x to the power 5 goes to plus infinity.
To infinity.
This entire thing is going to, this is going to minus infinity, and minus minus means plus. That means this entire thing will go to plus infinity. That means your polynomial goes to plus infinity. That means your graph should look like when x tends to infinity, your px tends to minus infinity, like this one. And when x tends to minus infinity, your px tends to plus infinity. When x is moving here in this direction, then the height is becoming more positive, right? Extending to minus infinity, height becoming more positive. Tending to infinity, that means this. The n-term behavior should be like this. So if you move your polynomial to the right in this direction, it will move to to minus infinity. The height will keep decreasing in the negative side. And if you move to plus infinity, the polynomial's height will keep increasing on the positive side. Is that okay? Then this is, we've already discussed this thing, but let me just highlight this one more time. Let's say you have your fx1. There's one point where your fx1 is, or we're discussing polynomials, so let's take polynomial only. So if you have px1, let's say px1 is 0, is less than 0, and px2 is greater than 0, then this should imply that at least one root, there could be more than one roots. At least one root of px lies between x1 and x2. I think we're done with the whatever theory was left. If there are any doubts, you guys can ask. Do we have doubts? Does anyone have any doubts from practice assignments, activity questions? Have you guys tried questions?
I have some doubts. Let me just check. I have shared the doubts.
You just tell me the doubts because I'll have to open the chat box again and again. So
Extra practice, week 4.
extra practice. Which question?
Question 3, 4, 6, 11. 60.
So a cubic polynomial is of the form px equals this. Which of the following options are correct? This is a cubic polynomial where what is this? Well, why do I feel like there's something missing in this question? Is it about root? What is this thing about? The first option and the second option and even the third one.
Sure.
I think it should have been P1. But if it's P1, then these two options become same. So if you talk about P1, that gives you A plus B plus C plus D. That gives you sum of roots. Sum of no, it doesn't even give you sum of roots. It gives you nothing. So what is this option? These three options about it? I'm not sure. Because minus B by A is basically I think the sum of roots. So if you have alpha, beta, gamma as roots, then like this one. If you have alpha, beta, gamma as roots, then alpha, beta plus beta, gamma and this thing should be the fourth option makes sense. The other three, I don't know what they're asking about in the other three. I'll just there has to be a mistake in the first three options then. And this is sum of roots taken two at a time. So I think sum of roots taken two at a time is for quadratic ones, it's minus b by a and c by a, right? And for this one, I think it's minus b by a, c by a, and minus d by a. So it goes like this. This is for sum of roots. This is for sum of roots taken two at a time, and this is for product of roots yeah, this is for product of roots. It's fine. That means this option should be correct then. And I don't know about the first three options. What are they talking about? So if the graph of coming to this one, if the graph of the polynomial px has roots x equals to 3 and even multiplicity with even multiplicity and x, so you have one root as x minus 3 with even multiplicity and x minus 2 with odd multiplicity. So the other
X
one
plus
is this
x plus 2, yes.
plus 1. Then the following are correct. So the minimum possible degree of px can be, so if you have to take the minimal possible, this has to be, because this is even, so it will have to be 2, right? You can't take 0, because 0 will just mean x minus e to the power 0 just means 1, and that means 3 is not a root. So you can have at least 2 here, and here because the multiplicity here is odd, so you should have 1 here. So the minimum possible degree is 3, right?
Yeah.
This option should be correct. The degree of the polynomial px can be even. Now coming to the even part, if this is 2, that means this is even, right? That means the degree will be multiplicity of 3 plus multiplicity of 2. And then it's pretty possible that there could be other things too, right? Like, okay, let's take this thing.
So least degree would be 3, so which is not an even.
No, they're asking if it can be even or not. They're not asking if the least degree is even or not. The minimum possible degree is even or not. They're not. Okay, let's do this option. Second option says, so the degree of this is even, this is odd, right? So even plus odd, and then you can have something else too, right? Like if you have x minus 3 to the power 4, x plus 1 to the power 3, and it just says that these are two roots. It doesn't even say that say that it does not have any other real roots, right? So it can have other real roots too. It can have minus 1 here. That's also a possibility, right? Is this clear?
Yes.
That means you can have degree 4 here, degree 3 here, and then you will have a degree here as well. You can have something like that. You can have x minus 2 square here. That's also fine. That means even degree is possible, right?
Yes.
Coming to the third option, we have the value of the polynomial px at x and at infinity and minus infinity will always be of opposite sign. If you have only these two roots, the problem here is because they've not mentioned that it only has two roots, 3, or only two real roots, 3 and minus 2. Because they've not mentioned it, that means you can't really say anything about the signs here, right? Because if you have this thing, let's say you have, your degree can be even because of the fact that you have not mentioned that there are only two real roots, 3 and minus 2. That means your degree of px can be even or odd. It could be anything, right? So if it's anything, then you can't really talk about what happens when it goes to infinity or what happens when it goes to minus. But if you have been given, let's say you have been given only two roots or only two real roots, if 3 and -2. Then what happens? Then the scenario changes. Then the second option might change as well, because now you have, let's say you have this thing. This is even, this is odd, and then you don't have any other real root. If you are assuming that there are only two real, these are the only two real roots, but you can still have complex roots, and they'll be, so if you have a complex root, the degree of that root or the multiplicity of that root will be even, right? So degree of px will be even plus odd plus even. So this is coming from multiplicity of 3. This is coming from multiplicity of -2. And this is coming from complex roots, right? Now even and even, two even numbers added gives you even, and even and odd when added gives you odd, right? That means now you can't have this option correct. Is this fine? But in the question, it's not if the graph of polynomial px has roots 3 with even multiplicity and x equal to 2 with odd multiplicity, because it does not mention explicitly that it cannot have any other real roots. That's why this option becomes a little vague. Is this okay?
Yes.
Are you following?
Yes. Yes.
Okay. So if you assume that your only real roots are 3 and -2, then this option has to be incorrect, because we just checked that this sums out to be an odd number. Now coming to this one, now we can talk about this one more clearly. The value of the polynomial px at x, when x, now if x tends to infinity, because your degree is odd, right?
Odd. Then
And the other thing we need is the leading coefficient, and we don't know what's the leading coefficient. If you take this thing,
based on this, we
see,
can take.
no, we can't take, actually, the if you've only been given this information that your roots are 3 and -2, then it's possible that your polynomial could be x minus 3 square x plus 2, or it could be minus x minus 3 square x plus 2, right? So the things are going to change. Both of these are possibilities for the polynomial. But now if you take this one, for this one, if your x tends to infinity, where does your px go? So from here you'll have, for x cube, the coefficient will be 1, right? So if x is tending to infinity, so the leading coefficient is 1 here. And the leading term is 1x cube. 1x cube. So if your x is going to infinity, 1x cube will go to infinity. That means px will go to infinity. And if your x goes to minus infinity, your px should go to minus infinity. Because if x is going to minus infinity, 1x cube will go to minus infinity. That's why px goes to minus infinity. This will be the case. Now, if you have this polynomial, then the things will change entirely. If your x goes to infinity, px without a negative sign, this thing was going to infinity. That means this thing goes to minus infinity, right? It becomes the exact opposite. Is that okay?
Yes. But option C is correct. I'm not sure how. That is the confusion. This question.
So it says they'll always be opposite, right? If you have px tending to infinity, here your px tends to minus infinity. That could be found out. This is when x tends to minus infinity, your px should go to, when x was going to minus infinity, this thing was going to infinity. That means this thing should go to, when x moves to minus infinity, this moves to minus infinity. That means this thing should move to infinity, right? So no matter what you're taking, in both these cases, Px is moving to opposite polarities, right? One time it's going to, that
Like
means if x goes
opposite
to,
polarity.
right, this is positive, then this will be negative. If this is positive, negative, this will be positive. Is that okay?
Okay. Acha, you only focused on infinity or minus infinity.
Yes.
I neglected the opposite side.
These have to be of the opposite sign. That's what your option says, right? It
Yeah.
says the value of px at infinity and minus infinity will be of opposite sign. This should be correct. And then the fourth one is the polynomial px touches the x-axis at x equals to 3 and cuts the x-axis at x equals to minus 2. So
In that I got, I don't have any confusion.
you're clear with this one, right?
Yeah, I'm clear. I'm
Okay.
only confused with why option C. Like I was only considering plus one. I didn't consider the negative one also. In that way, yeah, then it makes sense. In question number 6, what is the difference between option B and option D?
1 second, let me check what's of question 6. Let px be a polynomial if p1 is minus 5, p2 is 3. That means they have opposite sides. At 1 and 2, at this point you have something negative, and at this point you have something positive. That means you should have a root between these 2 points, 1 and 2. There should be a root between 1 and 2 for this polynomial. Which of the following statements is correct? Px has a root at x equals to 1.5. This is not necessarily true. It's true that if this option said px can have a root at x equals to 1.5, that is true. But this one, because it says it has a root, then it should be incorrect. Px has one root between x and x equals to 1 and 2. This should be correct because we see that there is a root between 1 and 2. This should be correct. Px has at least one root between x equals to 1 and x equals to 2. Okay, this I didn't focus on the at least part. This says it has one root. Now this option means, although it's not written that it has only one root. This is all about the language here. Because it doesn't say it only has one root. Now, if this thing means that it only has one root, that means it cannot have more than one root between 1 and 2, then it's incorrect. But if this says, okay, if this option means has only one root, then it's incorrect. But if this means has one root and can have more than one root, then it's correct. But considering the third option, it looks like it means this only, has only one root. That's why this should be incorrect.
At least one root will be correct.
And you should have at least one root. You can have more than one root. This is a possibility. This is also one possibility. 1 and 2. And you will have things like this. This is also a possibility. So this should be correct. You can have one root and more than one roots. So there exists alpha belonging to 1, 2, so that f of alpha is 0. So this is the symbol for there exists. That means there should be at least one. This means there is a number alpha in this interval where the value of your function becomes 0. That's what this fourth option means. And there indeed is one point between 1 and 2 such that your function becomes 0 there. Right? So this option should be correct as well. Is this okay?
Ma'am, but it should not have closed brackets, right? It should not include 1 and 2, right?
So when you say there exists alpha belonging to 1, okay, you're saying it should have been there exists alpha belonging to 1, 2, right? Now let's say your
Yes.
alpha is 1.5. Let's say this is 1.5. This belongs to 1, 2. If something belongs to 1, 2, does it not automatically belong to this interval as well? That means it belongs here, right?
So if we take P1 that is given -5, that means the coordinates are 1 and -5.
Right. This point will have coordinates 1 and -5.
Yes. Similarly, for P2 is equal to 3, that means these are of coordinates 2, 3.
Yeah.
So that way, I just make sense like it would cut x-axis somewhere in between this 3 and 1. So
Yes.
that
If you cut the
way,
x-axis, yeah.
that way I approach this.
That's what we said. That's what we're trying to say, because your polynomial is, what happens is, if it's not a polynomial, then it's pretty possible that one point is here, one point is here. So here, and you will have to, for this to maintain continuity, you will have to cross this graph, this line,
Yes.
right?
Yes.
If it's not continuous, then maybe you can have something like this, and then it doesn't cross this, and this goes like this. That means it might not have a root between these 2 points, right?
By that logic, I only approach
Yeah, that logic is correct. That is the only logic there. So, okay. Anything else? Is this question clear?
Yes. 7, 11, 16.
This is 7. So this says that if there's a polynomial px, and if px is divided by x minus 1, the remainder is 3. Now we've discussed this. What does our remainder theorem say? You don't have to remember the name of theorems. But it says if you divide px by x minus 1, then remainder is p1, right? So this means that p1 should be, as per question, your p1 should be 3. When px is divided by x minus 2, so in a similar way, when px is divided by x minus 2, so p2 is remainder when px is divided by x minus 2. So that means, and the remainder is given to be 5. That means this is 5. So you have to find the remainder when px is divided by x minus 1, x minus 2. And okay. We're not given the degree of the polynomial, that's the problem. That, okay, let's just assume that if you have x minus 1 here, I don't think this information is complete to find the remainder. Because for remainder, there's no direct formula for you to find the remainder for x minus 1, x minus 2
That's
as
what.
such. And you will need the degree of the
This
polynomial. So
question,
Can you reconfirm
the
whether
difficulty
there is a
is
typing mistake or any piece of information is missing?
there has to be something missing. And I think what's missing here is because all of the factors that are given to you are they are in linear generally. So I'm assuming that your polynomial is of degree 3. And if it's of degree 3, it will be ax cubed plus bx square plus cx plus d. And if you substitute 1, let's substitute 1 here, you'll have a plus b plus c plus d equals 3. That's also incomplete information, by the way, because, and if you substitute 2, you'll have 8a plus 4b plus 2c plus d equals 5. And there are 4 variables with only 2 equations, so it's not feasible for you to find all of these ones.
Okay.
I think there is
it's,
some information with help. Yes. What?
It's some left.
Can you please write it in chat box because your voice is breaking.
Said that some information in the question is left. That's why.
Yeah, that's what I said. It's some information is missing from this question. There has to be more information for you to find the answer. Is that okay?
Yeah. Fine.
Okay. And what other questions? Are there 11 and just 1 second. 11th question is this is it. Polynomial px has root of multiplicity 3 at x equals to 0 and a root of multiplicity 2, where you have 3 multiplicity and at 2 you have 4 multiplicity. Which statement best describes the graph near x-axis? Near the x-axis, it crosses the x-axis, crosses at x equals to 0 linearly and turns at x equals to 4. So it's possible for it to cross this graph linearly. Linearly means this thing. And sometimes it also crosses like this, right? That's not linearly. But if you have multiplicity 3 here, then it can't cross linearly, right? When you have degree 3, basically what happens is when the multiplicity of a root is 1, then it usually looks like this. The crossing looks like this, almost a straight line. And when you have degree 3, it is
Then
usually like this.
it's just slight.
It's like this. Yeah. So this is for multiplicity 3 and this is for multiplicity 1. So it can't cross it linearly. Linearly anyway means one multiplicity, right? So at x equals to 0, because the multiplicity is 3, it can't cross it linearly. That's why this should be incorrect. Then it flattens while crossing at x equals to 0. And the x-axis is tangent to the curve at x equals to 4. So if you'll have, because the multiplicity at 2, the multiplicity is even, right? So it should be either this or this. Now, if you will draw a tangent at x equals to 2, then the tangent will be, what will be the tangent?
The x-axis.
Right, it will be the x-axis.
Axis.
So the axis, that means your x-axis should be the tangent, right? We should have mentioned x here. X-axis is tangent to the curve at x equals to 4. And it flattens while crossing at x equals to 0.
Yeah, it flattens.
Yes, ma'am. This is correct.
Well, how do you exactly describe it flattens while crossing at x equal to?
Okay, if you have something like this, it will be this thing, right? If your multiplicity is 3, it's basically your graph is either this way or it's this way. So flatten, I think it means this thing. Because if you have a tangent here
Somewhat
at this
flattening in
point,
between.
what?
I said that it's somewhat flattening in between
Yeah,
with
if you,
multiplicity.
yeah, this thing is at fact, basically it will draw a tangent here, no? At this point, that's also x-axis. So at this point too, your tangent is x-axis, and at this point too, your tangent is x-axis. Flattening in the sense that if you zoom on this thing, right? If you zoom on this area, it will look like this. You can try this on Desmos or some other graphing application where you can try to plot the graph of x cube, and then you will see it looks like this. So this is flat. If you zoom on this part, it will look like this. It looks flat. If you zoom in,
Yes,
that's what we mean by flattening.
Can you take question number 11 also?
And let's get done with this one first. It is tangent at x equals to 0 and crosses at x equals to 4. It doesn't cross at x equals to 4. This has to be incorrect. It stays above the x-axis at both points. At both points, if you have, if these are the 2 points being talked about, x equals to 4 and x equals to 0, then it is on the x-axis. It doesn't stay above the x-axis. Is this fine? Wait, yeah, which next question, which question should we take up next?
11.
11.
Extra.
Consider the quadratic function, two quadratic functions, this and this. A quadratic function fx has its vertex at the intersection of the points y1 and y2. So first you have to find the intersection of y1 and y2. And it will be, I guess, there's just one point of intersection, right? You can equate these two things.
But the thing is that I, understood, I found their vertex and I found their y-intercept of both equal curves, and but unable to get the intercept.
Okay, let's see. This has its, the third quadratic function has its vertex at the intersection of these two quadratic functions, right? And the intersection is x equals to -2. So if I put -2 here, I'll have 4. Then if I put here, so it will be -8 plus 1. So this is -3, right? So y will be -3. The point is -2 comma -3, point of intersection. Then it further says its y-intercept is 2. So that means if you have ax square plus bx plus c form, then c is 0, right? Because y-intercept is when you substitute x equals to 0, so c should be 0. C should be 2. Y-intercept is 2, so c should be 2. And its axis of symmetry is parallel to the y-axis. That means it's of this form. Axis of symmetry is parallel to y-axis, that means it's this. Or this. It could be any of these. I don't know why this is even given to you, because if you have a quadratic function, then its axis of symmetry is obviously parallel to y-axis. That's the feature, one of the features of
yes,
quadratic functions. This information is redundant. What is the equation of fx? So to find the equation of fx, where c is 2, then you're left with ax square plus bx plus 2. and one of the points that satisfies this is minus 2. Its vertex is minus 2 comma minus 3, right? Vertex
2 comma minus 3 I got. My the y-intercept for y1 is 1 and vertex is coming as 2 minus 3. For y2 it's the y-intercept is minus 3 and vertex are 3 minus 12.
Why do you need the y-intercept of y1 and y2?
Just to
It's
plot
just
the curve.
at the intersection points of, we just need you don't need to plot
X
the
is
curve.
minus 2.
It's not required. And x is minus 2. You must have made a mistake. This is the vertex. And the vertex is given by minus b by 2a. That means your minus b by 2a is minus 2. And f of minus b by 2a, if I'll substitute here, this will give you b is equals to 2a. So you can substitute b equals to 2a here. You will get ax square plus ax plus this is equals to fx. And f of 1 second. What is the vertex that we've got? Why are we even doing? Because this is not, you have been given options, right? We can test these options. We don't have to do this and solve this entire thing. Let's check whose vertex is minus 2 comma minus 3. So the vertex of this is minus 2 and this is the same as, just 1 second. You write these things. This will be x plus 2 squared and then y minus 13, right? That's what matters. And this is minus 11 by 4. So this gives you minus 2 and 13. 1 second. We have 13 everywhere. Is this incorrect then? Just 1 second. If I substitute minus 2 here,
Yes,
in
ma'am.
what am I going to get?
Minus 3 will not be there. It will be minus 2 comma 13. Yes, ma'am. Because that 4 plus 8 plus 1.
This should have been
That should have
13.
No, ma'am. That y will. That should be minus 2.
That's what we're changing. Okay, this is x. This is minus 2 and this. So this is minus 2 and your y-intercept. Okay, your vertex is minus 2 and 13. Minus 2 and 13 is what here? Minus 2 here and 13 here. That means it's here. Now, and it says that it intersects the y-intercept at 2, right? So that means if it is a downward parabola, there's no way it can intersect the y-axis at 2, right? That means it will have to be an upward parabola for this to intersect at 2. Now this point will be 0, 2. Is this clear to everyone? Why this? It's not given to you in the question that it's an upward parabola, but this is how you figure out, because it says that the y-intercept is 2. That means it has to be an upward parabola for it to intersect the y-axis at 2.
The
If it,
first option is satisfying.
so that, how's the first one satisfying? You have a negative here. This should have been positive, right? If you have this thing, y minus y naught equals kx minus x naught squared. That means y naught x naught comma y naught is the vertex. and k greater than 0 implies upward parabola. And k less than 0 implies downward parabola, right? So here your k is negative. That means it's a downward, according to this one, the parabola should be downward. But according to the information given, it's an upward parabola. That means this one should be the correct one, right? Is this okay?
Yes.
This is obviously incorrect because k less than 0 means the parabola is downwards, but our parabola is upwards. It opens upwards. That's why this is incorrect. Negative. This negative is incorrect. Actually, you can eliminate all of these because
The exact
it
answer
opens
is
up.
option A.
This is
Option A
it.
is the
Is
right.
it? Okay, let's check again if we've made a mistake somewhere. We have been given the point of intersection. I don't think the point of intersection is incorrect, and that's not something that's incorrect with this equation. The problem is with k, right? The leading coefficient is creating the problem. This one second. So the leading coefficient is it says that your y-intercept is 2 and your point of intercept. Okay, this does not lie here. That's a we've made a mistake in plotting the graph.
Yes, ma'am. That
This
will
point
lie
does
in
not
the
lie here.
second
Yeah.
story.
This point because I thought this is y and this is x, so we did this here. Your x is negative and your y is positive. That means it's somewhat
Second quadrant.
second quadrant, and it's upward, so it should be here. Now, if it opens downwards, now this height is how you can check this. Just using the graph and not doing any calculation is this height is what's this height? The point is minus 2 comma 13. So this height is this point is 13, right? This height is 13. Now your vertex is if it opens downwards, if this height is 13 and your 2 is y, it says your y-intercept is 2. That means it's a now if it opens upwards, so it's going to intersect the y-axis above 13, right? Is that
Yes.
okay?
Yes. Yes.
If you want it to intersect here at 2, you'll have to take the downward parabola. That means the parabola should be downwards. That means this option, the first option that gets eliminated is the C one. This gets eliminated first. And then the remaining are these ones, right? So this one has a vertex problem, right? It
Yes,
says
ma'am.
your vertex should be 2. So this is incorrect because this option says the vertex of the x coordinate of your vertex should be 2. And we have minus 2 here. So this is incorrect. And then this says that the y coordinate of your vertex should be minus 13, right? But it's 13 here. That's why this option is incorrect. The only option that you're left with is A only. And you can also check. This suggests that your this is this, right? So if this is it, that means minus 2 comma 13 is the vertex, which is true. That's the vertex that we have found. And minus sign indicates that it opens downwards. That's also true because that's what we have found. Is that okay?
Yes.
And then 16th question you said, right? Do we have a doubt in 16th question? Because I remember someone asking the 16th question.
Oh, I was unable to solve it.
Okay.
That way now we have alpha, beta,
Right.
gamma.
Alpha, and beta. This should be equals to minus b by a, right?
Initially I didn't have that, but now I can do it.
Okay. So you don't want to use this information, is it?
Yeah, I wasn't aware about this information.
I think we can substitute.
One way is to substitute. And let's say you're not given the options, then you'll have to do this.
So simply we can
That minus b by a will be
b by
Yeah, we want to do this without this information. For a cubic equation, obviously this makes things easier. For a cubic equation, sum of roots is equals to minus b by a. So if your cubic equation is ax cubed plus bx squared plus cx plus d equals to 0, then the sum of roots is given by minus b by a. Product of roots is given by minus d by a. And sum of roots taken two at a time
b by
taken two at a time simply means that if roots are alpha, beta, gamma, delta, alpha, beta, gamma, then sum of roots, which is alpha plus beta plus gamma, is minus b by a. Product of roots, which is alpha, beta, gamma, is minus d by a. And this taken two at a time is alpha, beta, gamma, and gamma alpha. This should be c by a.
b by a.
So if you don't want to use this information, then how do we proceed? You have two equal roots. That means you will have x minus k square dividing this thing, right? You can use this thing where you will have to divide and then you will get the, can we use this 4x cubed plus 20x square minus 23x plus 6. And if you will divide, you will have, this is just x square plus 2kx let's consider the root to be minus k. That makes things easier. So if you'll consider it to be minus k, then in the factor you can take it to be x plus k square, right? So this will be this plus k square. So you will have 4x here and 4x cubed here. Then 8 kx square and then you will have 4k square x. This will give you 0. This will give you 12k. No. This will give you 20 minus 8k x square. This will be 4k square minus 23 x. And this will be 6. And next you will have 20 minus 8k. This will give you 20 minus 8k x square plus 20 minus 8k and 2k times. So this will be 40k and this will be 16k square, right? And then at the end, you'll have 20k square minus 8k cube, right? So this will be 0. This will be 4k square minus 16k square. So this will be 20k square. minus 40k minus 23. And there you have 20k square minus 8k cube plus 6. Now for this is the remainder, right? Because now you have the terms in x and constant one. This is in x, this is in constant. So this is a linear remainder now. And we can't go beyond that, right? Because the degree here is 2. The degree here has become less than 2. That means this is remainder. So you need to equate this remainder to 0. If you equate this thing, you will have 20k square minus 40k minus 23 equals 0. What are the roots that we're getting for this? So 60 times 4. This is and here you will have 40, right? So this is just calculation heavy, a lot of calculation. Then you'll have to, can someone calculate the square root of this thing? I don't think there's a perfect, this is a perfect square. What's in there?
It's coming to 58.65. It's not perfect.
They are not a perfect square. So and we should be getting some one of these values here. Negative of one of these values, that means we have taken the root to be minus k. Have we made a mistake in the division process? Someone spot a mistake anywhere?
I think you have missed X here.
Right.
Yeah. Just here, 40k, but you have mixed X here.
Where I've added both of these, right? 40k will become minus 40k. This will become 16k square, and we have 4k square here. 20k square, and then minus 23 will remain minus 20.
I think we could have just put it in alpha plus beta plus gamma is minus b by.
This
So
one
we-
you're talking about, is it?
No, that first one, sum of roots is minus b by.
Yeah, that's what I said. This
As
expression is
it's
what you're
same,
talking about,
then
right?
as it's same, then 2 alpha plus gamma will be equal to minus 5 by the question. So minus 5 minus 1 minus 6.
I think going by this process is taking very long, and it's a very
Yes,
lengthy
ma'am.
process.
Mostly taking very long, and also it's
So
high
it's
chances
just
that mistake can be done.
yeah, the high chances of mistakes while calculating stuff. So you can just avoid this thing unless there is no other way left. Just avoid long calculations. Try to use the quick formulas that you have. do it using this way. Is it okay? Should I do it this way or this way?
That's where you can.
Can't hear you.
Yeah, this way you can do.
Okay. So two equal roots are alpha and then let's say the other root is beta. So you'll have two alpha plus beta. Now you have two variables here. One is alpha, the other one is beta. You have to find the roots, right? So let the roots be alpha, beta. Then your alpha, this sum of roots should be minus d by a. And minus d by a is minus 20 by 4.
Minus
Right? So it's minus 5. And then you'll need one more equation to find the value of alpha and beta.
no,
Now,
no, but
once
alpha
Product
there
of root.
if you're not using these options, then you'll need one more equation, right?
We can use product of roots.
Yeah, so let's take
Alpha
product
square
Yes.
beta.
probably
this will be minus d by a. Minus d is 6 by 4. So this is minus 6 by 4, which is minus 3 by 2. So from here you'll have beta equals, okay, let's find beta will be equals to minus 2 alpha minus 5 from this one. This will imply alpha square minus 2 alpha plus 5 should be equals to minus 3 by 2. Now it actually is going to give you that equation back, I think. If you do this thing, I think you're going to get the equation back. And if you have this thing, let's use this one too, if anything gets easier. Alpha square plus alpha beta and alpha beta, so it will be 2 alpha beta. This should be equal to c by a, right? So c by a is minus 23 by 4. These equations are actually, let's try to use the options only because these, if you solve this entire thing, I think you're going to get this one. You will have alpha square and then
yes,
2 alpha plus 5. So this will result in the same equation. Because this is
I
also a
think
cubic
selecting
equation.
from the options is
Yeah. Or maybe you will have a less complicated. This is minus 3 by 2, right? So you'll have a cubic term here, then a square term here, and then a constant term here. It will not be exactly this equation, but it will still be a cubic equation that you need to solve. So it's just better for you to substitute these things here and check which one of the options is correct.
Got it.
Because this is going to result in 2 alpha cube plus 5 alpha square plus 3 by 2. This is again a cubic equation. For this, you'll have to solve a cubic equation. A simpler one than this one, obviously. So you have half, and minus 6. You can try substituting this here. You'll have half here, 1 by 8, 5, 1 by 4, and 3 by 2, which you can write as 6 by 4. Or, right, 6 by 4, this is 1 by 4. So this is 6, and 5, 11, and 12 by 4. So this is 3. But you don't get that, means this should not be the correct option. Half cannot be a root.
it should be
Then let's come to this one. Let's substitute 3 by 2. You'll have, okay, wait. Right.
some
We've not
sign
made any
mistake
mistake.
is
What?
that beta should be equal to minus 2 alpha minus 5.
If you will take a negative here, okay, that might change things, right? This will then become minus 2 alpha cube minus 5 alpha square plus 6 by 4 equals 0. And if you substitute things here now, 1 by 2, so this will be minus 1 by 4 minus 5 by 4 and 6 by 4. Yeah, this is 0. Okay. That means one of the roots, the double, either this option is correct or the second one is correct. This one or this one. So let's try to find the value at 3. You can't use this equation. Your beta should be
Yes, ma'am.
equals to, so if your alpha is half, you can use this. If your alpha is half, then beta should be equal to, by this equation, minus 5. This is minus 5. So this will be 1 plus beta equals minus 5. And this means that your beta is equals to minus 6.
Minus 6, yes.
So the other one should be this one.
Got it.
Anything else?
Ideally, they won't be asking this complicated questions in quiz.
This one is not a very complicated question actually. Because
Yes,
you
ma'am,
can just
because if
substitute
values
easily.
are
Yeah.
given, then we can use the substitution.
If options are given, then there's
Yes.
no problem. But you won't be given just this question and then asked about rules as a subjective question. So that won't be given. Is it fine? Do we have anything else to discuss, or can we end this session here?
Yeah, we can end it.
Okay. Bye, guys.
Thank you.